As concerned with the previous video, with the introduction to function that we did, we learned so many things. But I want us to take a closer look at how we write our mathematical operations and how we can redefine it with functions. You see, the traditional way is a is equal to 9, then b is equal to 78, for example. Then we say c is equal to a plus b. Then we print or we output c. You see, then we get what? 87. But what if we can do it in a very different way, so that we want to be limited to using one mathematical equation, but you can use the same function for different kinds of mathematical equation? So let's redefine it. In this case, I would say define, then the function name. You see, I'm adding, so I use define add. Then x and y, I'm passing parameters. Then I would say I will define the function. So I would say z is equal to x plus y. Now in Python, if you want to return a value, you have to bring the return function. So I will say return what? Z. You see? Good. Now since I'm adding these things, a and b, I wouldn't have to change anything. All I have to change is this one. See, c is equal to what? A plus b. So I'll call the function here. So I'll say add. Then what? I'll pass these variables. So when I'm calling the function here, it will actually be what? Argument. You see, it says that add two missing arguments, x, any, y. You see, so it expects two positional arguments. So I have to pass the argument. So what am I actually adding in this function? It is a and what? B. You see, the error is now gone. So when I run this code, it will give me the same 87. You see, that is how we can redefine our code with functions. And then I am not limited to this only. I can actually print different kinds of, I can write different kinds of mathematical formulas here, or equation, for it to work using the same addition function. You see, yes. So I can say d is equal to, let's say, in this case, let's say I want to input my own figure. So in here, I will introduce you to how to create the input function and then input your own figure. Good. So I'll say d is equal to input. Then I'll say enter the first figure. So with the first mathematical equation, we assign default values, but this one we want to input our own figure. So d is equal to input, enter the first figure. Then e is equal to input the, so I'll say enter the second figure. Then the function, so I'll say add. So what am I assigning to add? So I'll say f is equal to add, then the d and e, so that will be my argument. Then I'll say print what? F. But this one, enter the first figure, you see it is in a string, so it will only concatenate a string. But when we add, when we enter figures, it will combine the figures, it will concatenate the figures. Let's try and see. So when I run this code, You see, the first one is here, is working, giving me 87. But here it tells me to enter the first figure, so I'll say 45. Then the second figure is what? 45. But you see that it concatenated 45 and then 45. It didn't really add. Yes, because this one is actually a string. So you have to tell the computer that no, I am actually using what? An integer. So it should help me do what? Add it. You get my point? Good. So I would say I'll tell the computer that D is an integer and then E is also what? An integer. So in Python, this is how you do it. You say D is equal to int, then D, then E is equal to int what? E. So this time you've told the computer that you are actually doing what? Adding figures. So let me comment this one and then show the latest mathematical equation. So running this code, enter the first figure, I'll say 45 and then 45. You see, this time it gave me 90. Good. You see, or if you think this code is actually long, you can say, you can remove this one and then say int. So let's say int input. So I'll say enter the first figure. Then in this one too, I'll wipe it and say input, then add enter the second figure. You see, so running this code, enter the first figure 45, enter the second figure 45. You see, it gave me 90. So it looks like it is so close to the output. So let me add colons and then spaces so that it will actually be nice. So 34 plus 78. You see how beautiful it is. So I have redefined the code. You see, so this time around you won't be using the traditional way. You'll be using a much better, precise and then focused way of doing mathematical equations. So let's actually create another function and then do it. So let's say I have this equation. I have let's say definition. Let's say I want to add in any other thing. Let's say I have define, let me give it a name, u to be our function name. Then I'll pass only a single parameter. So let's say a. Then I'll say b is equal to, let's say 5 plus 4 multiplying this one. So we want to actually multiply this, the parameter that we will pass. So I have to call it here. So I'll say int of a. If I don't bring the integer, it will look at it as a string, making our code wrong. You see, good. And then I'll return the function. So I want to return the function. So return what? D. You see, yes. But what if you can do it in a very different way? So I'll say return print. So it will actually print what? The D for us. Then I would say a is equal to what? Input. So we want to input a figure here, this one. So a is equal to input, enter You see, good. Then I'll call the function. So u will be what? D. Oh, it's a. Sorry, it's a. Why am I using D instead of B? Yes, so my code is now intact. So when I run this code, the first one, this one will come. So it tells me enter the first figure. So I will say the first figure is 67, then the second figure is 3, giving me 70. Then the next one, enter the figure. So this is the equation, 5 plus 4. Then let's say 2 to say 13. Easy, good. So 2 times 4 is what? 8. 8 plus 5 is 13. See, that is how the code works for functions. So functions are actually very interactive, more than using the traditional way. It doesn't look nice.